Suppose we wanted to evaluate this integral, and suppose we wanted to do it by our method of direct substitution. First of all, you're going to have to go through these steps, which can look quite daunting, but as you practice more and more, the steps will start to flow better from one to the other, and it'll become second nature to you, but it does require lots of practice. Before we actually get started with this, let's copy the problem back down again. Step 1 says to set u equal to the expression raised to the power. Here, that would obviously be x squared plus 3, so we set u equal to x squared plus 3. Step 2 says to compute du dx. That's the derivative of u with respect to x, which is 2x. Step 3 says to solve for dx. We can get rid of that fraction by multiplying both sides by dx. The dx is on the left, divide out, leaving you with du equal 2x dx. But remember, we're solving for dx, so we need to multiply both sides by 1 over 2x, so that the 2x's on the left divide out, leaving you with just dx. So now we know that dx is the fraction 1 over 2x multiplied by du. Step 4 says if the integrand has a numeric, which is just a constant, a number, a numerical factor, move it outside the integral. There is an 8, which is a factor of the entire integrand, so we want to move it out. Step 5, which is really the heart of the process, says to substitute both the u and the expression represented by dx into the integrand. So since we know that x squared plus 3 is equal to u, we can take that x squared plus 3 out and put it in u, and I also want to emphasize that that 8 still has to be written down as you go down. You're not doing anything with it, but it does carry down the process. So now I want to do the substitution. The x squared plus 3 is equal to u, so I put in u instead of that. And then, since dx is 1 over x times du, I put that in place of dx. All my substitutions are done. Now I want to simplify the integrand, and the first thing I notice is that the x's divide out. At this point, you should be rid of every trace of x and dx in the problem, and here you can see, now that those x's divided out, that that's in fact true. You can also notice that the 1/2 multiplied by the du is just a constant factor, so you can bring it out front with the 8. And that leaves you with a very simple integral to evaluate. We do have one more simplification step. The 8 times 1/2 is 4. Now we can focus on the integral itself. The integral of u to the third du can be handled by the general power rule for integration, which is what step 7 asks you to use. That tells you that the integral of u to a power is obtained by raising the power by 1 and then multiplying by 1 over that new power. So since the power in our problem is 3, we want to add 1 to 3 to get 4. And then we want to multiply by 1 over 4, which is 1/4. You've got a little simplification here, of course. 4 times 1/4 is just 1. And also you always have to add a plus c on an indefinite integral. So doing both of those things, 4 times 1/4 being 1, and adding your plus c, you end up with u to the 4th plus c. Final step, step 8, substitute the x values back in, simplifying if needed. So the u goes out, because we put the u in ourselves. It was not in the original problem. Now, after we're done with our integration, we take the u back out and put back in the x squared plus 3, and we're done. And keep in mind, if you have any doubt that you got the answer right, all you have to do is take the derivative of what I've just boxed in there and convince yourself when you take its derivative, you get what you started with. You can always check these integrals by differentiating and see if you get what you started with. So if you end up with that answer, differentiate it and see if you get back the integrand that you started with. If you do, you know you got your integral right. In any case, there's your answer.